Hello everyone. Today we'll be discussing decoders, but before we start with decoders, I'll introduce you to two new, you can say, concept or things we use, terminology that we use, right? So I'll start with that. So there are two terminologies we use. It's active high. So in simplest term, active high means, let's say you have an input, right? Then you have your circuit here, or you can say, yeah, your IC or your logic circuit, and this is an enable input or a chip select, we call it. You can say chip select or enable, either works, right? So active high just, so active high just means when you supply one or when you supply one or high, the chip or the IC is on, or you can say enabled. So it just means the chip will be enabled or will be on when you supply one. You supply one or high, IC is on or enabled, right? In simplest terms, then active low is the opposite of that. So active low, you have that small circle in front, then your IC, you can say. It could be any IC, integrated circuit. Then again, you have your enable here and your chip select, or one of those two. So here, to uh, to switch on the the IC or enable it, you will have to supply low 0 volts or logic 0, right? Because it says it only activates when it's or it only activates when it's low. So active low just means it only activates the IC when you supply um, 0 or low the IC, or you can say activates the IC, or a better term will be, we can say enables the IC to, or enable the IC when you supply active low in this case. So yeah, so there are two ways to switch on IC depending on if it has a small circle in front of it or not. So if it's not, then it's active high. So you supply 5 volts or 1, the chip is enabled. Active low means you have a circle, so you have to supply 0 or ground to enable the chip. So just remember that. Now we can go to the decoders. So let's start with decoder. And in technical terms, decoder is a combination of logic circuits that converts an input binary levels into a maximum of 2 to the power of n, 2 to the power of n unique outputs. So I'll show you with a circuit diagram what they mean. Right. So let's just say you have a 2-bit decoder, right? Or 2 to 4 decoder. We call it 2 to 4 line decoder. So you will have your decoder here. So 2 to 4 line means you have 2 inputs and 4 outputs. Right, and you also remember you have a enable pin E or a chip select, you can say. So you'll have your input A and B. Right. And in this case you can see you have your, what do we say, then you have your output 1 0 1 2 3. So here you can see enable is, there's no circle in front of it, so this one is a active high, right? And even the output can be active high or low depending on what you select, right? So in this case even the output is active high, so you can say enable and the output both are active high. So this is 2 to 4 line decoder. So we have 2 inputs and we get 4 outputs. So what does it mean by when we get 4 outputs? Let's say then this one to switch on the enable the chip, you just say you supply 5 volts there, right? And let's just do the truth table, that will be easier. Then we have 2 inputs and 4 outputs, so 0 1 2 and 3, right? Then you can draw the truth table. So this just means when we supply 0 0, right? So both are 0, so we are looking for a value 0, right? So this is an input, so our output will be 2n. So in this case our n is 2, just remember that, and therefore our output will be 2 to the power of 2, which is 4 output. That's why we have 4 outputs, right? And the decoder simply does is, let's say you in binary you are writing 0 0. Let me just write the number here, 0 1 2 3, right? So in binary you are representing these numbers, right? So it's 0 0. So in this case it will select, so the output will be 1 will be 0 will be high, rest will be 0, because it's we selected, or we are outputting 0, right? So we'll have 1 0 0 0, and then again we do the same where we have 0 1, which is, you can say it's 1, right? So we'll select our output will be 1, so it will be 0 1 0 0, and same again. You have plus 1 0, which is 2 in binary, right? So 2, and that means it will select here 2. So as you can see, a decoder is simply uh, when you input a binary number, it gives you the line or the line number, the output of the line number, right? So here will be 0 and 1, and then when we have 3 1 1, that will be So our 3 will be high and the others will be low. So our 3 will be high. So in simplest example, this is what a decoder is. So when you supply 3 in binary, so it will select the line 3 output, right? Or 0 0, select the line uh, 0 so, and it does the same if you have a 4-bit or a 3-bit. I'll show you that. So this is our a 2 to 4 line decoder, and it's a active high, right? If let's say if we have an active low, so let's just say if we have a yeah, active low decoder, how will it look like? Active low decoder. We'll just use again 2 to 4 lines, right? So it will have the output also 0 and chip select. So again we'll have our output with a circle here enabled or chip select. Then our input is still the same. We have A and B. Our output will be 4 of them, but then small circle in front of it, right? Then we'll have 0, 1, 2, 3. And then to enable this, we will have to connect this to ground or 5 volts. So the truth table for this active low decoder, again we'll do the truth table 1, 2, 3. Then we have our truth table, right? And then again you can have here 0, 1, 2, 3, 0, 0, 0, 0, 0, 0. Sorry, 0, 1, 1, 0, 1, 1, right? So let's say if we supply 0, 0, then we know from the previous one, this one will be higher, right? This one will be higher. Or let me just show you what this means. This circle just means negative. So this is something like this. You have your NOT gate here, right? So here we'll have 1, but then the output will be 0. Then same goes here. We have 0, but it inverts, that will be 1, right? So it's something like this. So active low has a, you can say a NOT gate. So here will be 0, that will be 1. So our output will be something like this: 0, 1, 1, 1. Right, then we do the same for, if we have our input, let's just say 1 here. So this will be 0, 1. So this will be 1, 0, 1, 1. And the same, then we'll have 1 here, 0, 1, 1, 1, 1, 0. So wherever it was high, it is low, and wherever it was low, it is high. So active low does the opposite, right? So just to show how this circuit will look like. So just remember this active low circuit and circuit with active high, they are more or less the same, but just with a NOT gate. So again, we have our input A, B. Then as you can see, we have a NOT gate going in, right? Enable or chip select. And then again we have not, not, right, not gate, right? So 0, 1, 2, 3. This is same as this. You have your small circle here, you have your enable or chip select, then you have your input and output, right? Then you have your small circle here, 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 and here. So you have 0, 1, 2, 3. So you can see these two are the same circuit. That small circle just represents a NOT gate. So just remember that. Don't get confused, right? So in this is your 2-bit or yeah 4-line decoder, right? And then we get more. We get like uh, 3 to 8-line decoders. Right, so they will be like you will have 3 inputs. You can say it's going to be A, B, C. Then you have your, and some they have, I think so, 2 chip select. So you can have chip select, chip select, or enable. Then you will have 8 outputs. So you'll have from 0, 1, 2, 3, 4, 5, 6, 7, right? So when you supply, let's say 101, this in binary, this in decimal is what? 5, right? So 5 will be high and the others will be 0. And just remember this one is a active high decoder because there are no circles there, right? And then if I do just all of them on one, then our 7 will be high. So 0, 0, this will be high, right? So that's a 3 to 8-line decoders. And then the one I think so you have in your, oh, it should be there. You get, uh, you get 4 to 16 line, you can say, decoder. So you have 4 inputs and 16 outputs. It's the same. So our n is 4. Our output is 2 to the power of 4, which is 16. And this is a active low decoder. So you have your inputs. You can let's just say you have your 4 inputs. A, B, C, D. Then you have your chip select. You call that chip select 1, chip select 2, and then your output with a circle in front of it. Right, so it will be from 0 to 15. So you'll have 1, 2, 0, 1, 2, 3, 4, 5, 6, up until 15. And that is your active low decoder, right? Now in decoders we get like for example cascading. So let's do that. let's say they say you, for example, let's say in cascading they say use 232 8 line decoders to make for two 16 line decoders, right? So how are we going to do that? For two 16 line of decoders, and it's going to be simple. So what you will have is three, oh sorry, two decoders. Let's just have them here far apart. And you have your input, three inputs. So just remember when you are cascading decoders, so all the inputs are the same. So A goes with A, B will go with B, and then your C will go with C, right? Your C will go with C. So you have A, B, C, B, and C, right? Then you will have your enable or chip select here, your enable or chip select here. Then you will have your output. So this will be from 0 to 7, and this will be from 7 to 15, your output, right? And then our input will be lowest A1, A2, A3. So this one will be our LSB, and then we'll have our A4 here. We call this MSB. So this chip select line will be our fourth input, and that will go there with a NOT gate here, right? So this you can say it's so here we have made using 232 line decoder, and we made it into 4 to 16 line decoders, right? Yeah, yes. And just remember, we don't have any circle at the input or at the enable or at the output, right? So this one is what? An active high decoder, right? And then you can do the same. Let's say you have again you have 4 to 16 line decoder, and you want, so let me just rephrase this question. Then let's just use 2 uh, to make uh, to make it's going to be 5 to 32. And then you do the same thing. So here where you have let's say in this case we have an active low, right, decoder. Most of the time we use active low. So let's just say we have active low, and then we have our two decoders, right? So our enabled or chips are, so in this case we'll have two chips select. So this will be a circle there, and then we'll have a circle here and here. This is our chip select 1 and chip select 2. And those two are connected, 1 and 2. And just remember again, our output will be active low. So this output will be from 0 to 15. And then this output will be from 16 to 31. Active low. There is the output, right? And then again, our all four outputs are the same. So that is A, B, C, and then our last output, we just use another color. And D, right? So we'll have our inputs. So this will be A0, A1, A2, A3, right? Then we'll have our chip select. And just remember, in this case, it's active low, right? So now we'll have our NOT gate here now. Before that, then this one will go to there, right? And then we'll have our A4 here. So this is our four inputs again. This will be your MSB. That will be your LSB. AB, right? Yeah. So when you send a 0 here, it will be a 1. And when it goes there, it will be a 0. So it should enable, yeah, chip selected. So and if you check the nodes for cascading, okay, sorry, till it's there. Oh, okay, and see now I made a mistake. So our enable here again will be if it's 0, that will enable this chip. So that goes there, and again our ground will be here. That will be 1 and it won't enable, right? And then same goes for our active high. So when we supply 1 here, it goes 1. Or when we supply, so sorry, this one will be, that is my bad. So when we supply 0 here, so we have to activate this one, yes. So this one will be activated. Yeah, much better. So this will be our MSB. So when you supply 0, that will be 1. So this one will be enabled. And when we supply 1 here, this one here will be 0 and it will be 1. And the opposite for our active low. So just remember here, if you supply 0, this will be activated, that will be 1 here, so it won't be activated. Right. So that was our cascading for decoders. Now in decoders, and just also remember these decoders, we call them BCD2 binary. Uh, And then there are some different types of decoders. We have one which we call BCD2 binary. So this one will have 10 outputs. This one will have so BCD, just remember 0 to 9, so 4 inputs. Can have 1, 2, 4, 8, or A, B, C, D. Then you have your 10 outputs. So you just count from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you will have 9 outputs, or 10 outputs, sorry, 8 and 9. So if you supply, let's say, this will be your MSB, your LS, this will be your LSB and MSB. So let's say you supply 1100. So this will be number 3. So number 3 will be high, rest will be 0. And then you do the same. So this is your binary, BCD2 binary. And another one we get is, and that is your part of your experiment 4. That is part of your experiment 4. We get BCD to 7 segment. So BCD to 7 segment is the IC we use. This is the IC. We call this 74LS47. And then it has A, B, C, D, E, F, G. Right. And as you can see, it has active low enabled, right? So it has active low enabled, right? It's active low, let's just say that. I see. And then you have your LT not, there's a 0. Then you have your, I think so, RBI not. Then the last one is BI ROB, RBO, I think. Now then you have your four inputs A, B, C, and D. So A will be your again LSB and D will be your MSB. Right. And then you connect your 7-segment display like so. And just remember, I think so it's a 5-volt anode. So we'll have our A, B, C, D, E, F, and G. So let's say, for example, if we want to display um, 8, so we know which line should be high. And in this case, just remember, so it's active low, right? So which line should be 0 and which line should be high. And just remember, so we are supplying 5 volts. So it's something like this. So it's a current sinking. So let's just say it's the same as this. You have your LED, you're supplying 5 volts here, right? And then you have your A here. That's the same. So for this, for LED to be on, your A must equal 0, right? So, so here if you supply 0, LED is on. And if you supply if you supply 1, your LED will be off. So the same logic is used here. So when you supply 1, your LED will be off. Right. So just remember, if you want to display 0, so let's just draw the diagram for this. So let's just say we want to display 0, right? So we know to display 0, which LED should be on. So let's just use a red color. So we know this one, this one, this one, this one, and this one should be on, and this one should be off. So A, B, C, D, E, F should be on, and G must be off, right? So the input here must be what? A, so we'll have, so in this case A will be 0, B will be 0, C will be 0, D equals to 0, E equals to 0, F equals to 0, and G must be 1. And if you input these values, you will display 8 because it's a anode one, right? And same goes, let's say for example now you want to display maybe let's just say number 7, right? So let's just say you want to display number 7. So for number 7, just say this these LEDs should be on, the others should be off, right? So we know that is A, B, C, D, E, F, G. So in this case, our input A is 0, B is 0, C is 0, right? And then D will be 1, E will be 1, F will be 1, and G will be 1. So 1 represents it's off, 0 represents the LED is on. So just remember, when you're working with, you need to make sure of the logic, right? So that is your 7-segment display decoder. And sometimes you also might cascade them or join them together, right? The decoders for 7 segments. So let's just say, for example, you have 3 decoders, or you can say 3. I'll just write 747, 7447, 7447, right? Then I'll just represent it with one line. You have your 7 segment here. And you have your, let's just say, 7 segment here. Then you have 3 7 segments. Right. You have your 3 7 segment, and to connect them, you have your RBI pin. It goes to your BI or RBO pin. So these two connect like this. Then you do the same. You have your RBI, and that connects to ROB pin. Right, and then the other one RBI, this goes to ground. And then you can leave the LTO pin just like that, or to cascade, but we don't do it that much. But then when you do it, yeah, to cascade that. Right, and in this case, we call it, let's say, we call this a leading 0, meaning, let's just say, uh, uh, you want to display 070, right? So this is your this is going to be your LSB. Just remember the, or not bit, or decimal. So your this will be a 1, 10th, and hundredths, right? So you'll display 0 here, 7 here, but then this means leading 0. So this is a leading 0, and if you remove this 0, it doesn't matter, so it doesn't display 0 there. So yeah, that is what you call leading 0. And then you have another concept called trailing 0, trailing 0. So it's the same thing, but let's say, for example, you are displaying 0.720, right? So this 0 is not displayed. This 0 is not displayed. And your circuit might look something like this. So you will have your, again, your RBI, and then your BI or RBO, RBI, BI. or RBO, and then they are connected like so. And then you have your display here, 7 segment. So your 7 will be displaying your again 7 segment display, your 2 will be displaying, but this one will be blank because it doesn't affect the value you are looking at, right? And then you have your RBI here, and that goes to RBO, and this one goes to ground, right? So this was your encoder or decoder, sorry. What we have covered, well, most important one is sometimes they do ask to create a circuit for 7 segment display. So yeah, and I think so here at the bottom you will find the circuit for your BCD code driver, right? So this was the decoder. Okay, cool. Thank you.